let's take our sig fig discussion to the next level and start looking at how we analyze and apply significant figure rules to calculations. So in the first half of problem 12, letters A through D, we have multiplication and division. Remember that the rule for multiplication and division is that you always go with the least number of sig figs. Let's look at it together. So if I want to multiply 53.6, that has 3 sig figs with 0.41. Remember, the 0 out front is not significant because it's not to the right of the decimal point and it's not sandwiched or anything like that. So 2 sig figs here. So after multiplying them, I get 21.976. That's what my calculator told me. But I can only report this final answer to 2 sig figs. So I'm going to keep the 2 and I'm going to keep the 1. And then you always look at the next digit. If it's 5 or higher, you're going to have to round up. So I'm going to report my answer here as 22. Those 2 sig figs. Next problem. We have 65.2, which has 3 sig figs. And again, this zero's not anything. So just 1 sig fig on the next value. And we're dividing, so I'm going to go with 1 sig fig in my answer. When I threw it into my calculator, I got 326. How do we turn 326 into something with just 1 sig fig? So we're keeping the 3 for sure. We're looking at the 2. Well, that's not bigger than 5, so we're not going to round up. Several different ways we can do this. We could say that our answer is simply 300. And I would have to take that. It just has 1 sig fig and it's the correct answer. Another way you could do it though is with scientific notation. And this is usually the best way because it removes all ambiguity. So we know that just the 3 is important, but we don't want to leave it as a 3, right? There's a big difference between 3 and 300. So we'll do 3 times 10 to the 2, which if we convert that to decimal notation, that's our 300. But then again, it's very clear with that scientific notation that we just have 1 sig fig. On letter C, and again, if you're starting to feel confident, pause the video and do these ahead of me, right? Generate your answers and then watch this, I don't know, at quadruple speed and see if you got the right answers. You should be practicing these, not just sitting there listening to me talk, because that's pretty boring, right? So here we have 5 sig figs with this number and 2 sig figs with the 0.80. I'm not counting this 0, but this 0 is significant because it's to the right of the decimal place and it's to the right of a non-zero digit. This is a significant 0. Now we got 39,745.6 as the result when we throw it in our calculator. We need to change that to something with just 2 sig figs. So I'm going to keep the 3 and I'm going to keep the 9. Those are good. I have to look at the 7 because that's going to tell me if I keep it as is or I round up, and it's a 5 or higher, so I'm going to have to round up. So now I'm looking at something, 39 rounded up. We're looking at something like 40,000. But if I write down 40,000, I'm going to be wrong because 40,000 only has 1 sig fig in it. But we've decided that we need 2 sig figs. So here, this problem letter C is a little bit different than B in that you have a lot less options. You have to use scientific notation here to communicate the fact that you just have 2 sig figs. So I'm going to do 40,000, but I'm going to convert it to scientific notation. So that's 4 spots. So we'll do 4.0, because that 0 means something, times 10 to the 4th. And now I have my 2 sig figs. Next problem. It was in scientific notation. I love scientific notation, right? We don't have to think too hard about the sig figs. We just count everything. So this has 3. And when I say count everything, you're not counting the latter half of the number, just the digits out front. So in 9.3, that's 2 sig figs. And so our answer here has to be altered so that it just has 2 sig figs. So I'm going to keep the 8 and I'm going to keep the 0. The 4 isn't going to cause the number to change. So I'm going to do 8.0 and then times 10 to the negative 19. Don't forget about that exponent part at the end of your number. In the second half of problem 12, we're going to start looking at what happens to significant figures when we're adding and subtracting. So one way we can consider significant figures when we need to subtract is by counting decimal places. So since the 21 doesn't have a decimal point, I'm going to say that it has 0 decimal places. And 0.88, well, the 2 8s, that takes up 2 decimal places. Decimal places are completely different from significant figures, but we're going to use the decimal places to figure out how we should write this number. So since this has 0 decimal places and this has 2 decimal places, my final answer here can only have, I need to go with the least number of decimal places. So we can only have 0 decimal places in our final answer. So this number is going to be 20. Both the tens place and the ones place are valid. And so I need to indicate that. So I can do 20 point, or I can do 2.0 times 10 to the 1. Either one would be acceptable. And at the end of the day, we had 0 decimal places, but our final answer has 2 sig figs. Just want to emphasize that decimal places are used to analyze the result when you're doing adding and subtracting, but they are different from significant figures. The other way that you want to look at this, and this kind of draws more upon this idea that you're only as good as your worst measurement. So if you have the number 21 and then we subtract it, and I'm going to line it up like the way they taught you to in grade school. We're going to subtract 0.88 from that. I know if you were officially doing this, you'd have to put some zeros in there and do some borrowing or whatnot. But let's think about this in terms of measuring. We have no idea what's going on in the tens place with the 21. And we definitely don't know what's going on in the hundreds place with that 21. So these two columns are super questionable. So I don't want them to be in my final answer. So another important rule is that you're not rounding anything until you finish your calculation. So I do have to do 21 minus 0.088, and I get that 20.12 number. But at the end of the day, I don't want to include the tens place or the hundreds place because there's missing information. They come from incomplete columns, and I would just keep it at 20. So 2 different ways of saying the same thing, whatever works for you. Scientific notation. If you're counting decimal places, you need to be in decimal form. So it's not going to work to just analyze it like that. Or if you're going to do it this way, you still need to be in decimal form. I'll go through both ways super quick here on letter E. So let's change this. We're going to do 0.0568 plus 0.00645. So I just changed both of the given values over to decimal form. Now looking at these values, 1, 2, 3, 4. It's got 4 decimal places. And again, another thing that's different between decimal places and sig figs, zeros count as long as they're decimal places. I mean, this is not a significant 0. This only has 3 sig figs, but that's a decimal place. Same thing over here. 1, 2, 3, 4, 5. We have 5 decimal places. So since the first value has 4 decimal places and the second value has 5 decimal places, I can only report my final answer to 4 decimal places. So 1, 2, 3, 4. I need to stop at the 2. Always look to the right. That same thing holds true that we saw with the multiplication and division. Always look to the right, and if it's 5 or higher, we need to round up. So I want to cut it off on the 2, but this 5 is going to bump it up a little bit. So I'm going to report my answer as 0.0633. So that's 4 decimal places, but only 3 sig figs. And this is a lot, and you'll practice this on the homework, and then there's a worksheet for lab in the second week. Hang in there. I know this is a lot. It takes students quite a bit of time to master this. The other way, very quickly here, just in case this way of lining up the columns sits better for you, we're going to have these two numbers, the 0.0568 and 0.00645, and they need to be lined up with columns. And what we see here is that there's missing information. So when we add these up, we don't want to include that last column because it's not complete. The answer, the 0.06325, so this last column goes away, but the 5 still causes that to bump up. So on letter E, we have 3 decimal places here, 1 decimal place with our second value, and 2 decimal places with the third value. Since I'm just adding and subtracting, I'm going to go with the least number of decimal places, which is 1 decimal place. So my answer was 120.961, but I want to cut it off after 1 decimal place. The 6, however, is going to cause me to round up. So that's going to round up to 9, which we're going to get 121. Still have 1 decimal place. So we're going to report our final answer as 121.0. And by all means, you could use scientific notation as well. 1.210 times 10 to the second. That would work too. On the second one, we have scientific notation. So I need to look at that, consider that in my head in decimal form. So I'll do 0.028 for that second value. The first value has 4 decimal places. And the second value, when it's in decimal form, right, just has 3 decimal places. My final answer then can only have 3 decimal places. I'm going to cut it off after the first 7, but always look to the right. It's a 5 or higher. I'm going to round up. So we get 61.218 as our answer here. So in 13A, we're lucky because even though it's a pretty long problem, it's only multiplication and division. So we only have to look at sig figs. The first number has 1, 2, 3, 4, 5, 6 sig figs. I'm gonna count those zeros in the middle because they're sandwich zeros. Then we have 4 sig figs with the second number. these zeros don't count. They're not to the right of a non-zero digit. So we just have 3 sig figs with the third value, and then 3 sig figs on that last value. Throw it into the calculator. I got this really long number, but I know I have to cut it off after 3 sig figs. So 0.381, I look at the number directly to the right of the 1, and it's less than 5, so I'm not going to round up or anything. Put my final answer as 0.381. Alright, so letters B, C, and D. This is where it gets really tricky and a little bit tedious. An important thing to remember when you're doing these calculations with mixed operations and different rules is that you're not going to round anything until you get to the end. The calculator is going to do that for you automatically, so your best bet is to just plug this into your calculator the way it's written on the board, parentheses and all. That's how I got this value here. After that, you're going to apply order of operations. So in your head, you're going to say, well, what if the problem were just the part in the parentheses? What if all I was trying to do was add 0.881 and 132.1? How would I analyze my sig figs? Well, hopefully most of you would tell me, I'm going to look at decimal places, because I know that I'm going to go with the least number of decimal places because it's adding and subtracting. So we have 3 decimal places with the first value, and just 1 decimal place with the second value. So if you add up these two numbers, right, you're going to get 132.981. That's the whole value, and that's the value that needs to go on to the next step. But in the back of your head, and I'll draw my thought bubble here, in the back of your head, you're thinking, I only have 1 decimal place. So if I added these up, I get this answer. I really should be reporting it as 133.0. That 1 decimal place that you'd have if you applied the rules for adding and subtracting. That 1 decimal place corresponds to 4 sig figs. So that's in the back of my head. I'm working with this number. This number, even though the way I wrote it there has 6 sig figs, in the back of my head, I'm thinking this just has 4 sig figs. And this number over here also has 4 sig figs. And since I'm up to my multiplication step, I'm going to do something with 4 sig figs times something with 4 sig figs, which leaves me with just 4 sig figs in my final answer. I'm going to cut it off at the decimal point. There's a 4 to the right, so my final answer is 1,598. Let's look at 13C. So we're going to apply order of operations again, and we're not going to do any rounding into the end. So I'm going to tackle the parentheses first. We have addition, so when we're analyzing the sig figs in this section, we're going to look at decimal places. I have 2 decimal places with the 44.11 and 3 decimal places with the 1.223. So when I add these up, my answer only has 2 decimal places. So I'm thinking if the problem were to end right now and the rest of the problem did not exist, I would be reporting my final answer as 45.33. How many sig figs is that? That's 4 sig figs. So here, even though I'm not rounding, because you're going to keep the whole number till the end, you're going to think that value has 4 sig figs associated with it. And this value also has 4 sig figs, because that 0 at the end is to the right of a non-zero and to the right of a decimal point. And same thing with this 0 here, it's significant. So 1, 2, 3, 4, 5 sig figs on the first value. I kind of jumped ahead and started analyzing sig figs because at this point, once I get rid of the parentheses, I just have multiplication and division. And I'm going to apply the rule for multiplication and division, which says we go with the least number of sig figs. So the answer that I got was this long value here, but I have to cut it off after 4 sig figs. So I'm going to do 1.174. The 2 isn't going to make a difference. So my final answer is 1.174. So 13D, I'm going to multiply first. So I'm going to look at sig figs. First value has 4 sig figs, and the second value, the 0.3, that just has 1 sig fig. So if the problem were to end at this point, I would have to round the 3.603, the result of multiplying those, to just 1 sig fig. So I'm going to make note of that right there. That only has 1 sig fig. This we haven't done anything with, so we can say that it still has 4 sig figs. When we add, we're looking at decimal places. So this has 1 sig fig, which means the 3 is significant. So as a result, it has 0 decimal places. Over here, we have 3 decimal places. So our final answer, since our second operation is adding, our final answer can only have 0 decimal places. So we're looking at an answer of just 8. Let's take a second here and look at exact numbers. Exact numbers are associated with values that we can easily count, like the number of people in a room. We're not going to have half a person or something like that. And they're also associated with things that are clearly defined, like certain constants, our metric system conversion factors. So this is by definition. 1 meter equals 100 centimeters. That's how they set up the system. So this is an exact number, and when we use this value to convert, it's not going to impact our sig figs. It doesn't matter that there's just 1 sig fig there. Don't worry about it. It's exact. On the flip side, the mass of an empty beaker. Think about the scale, or even you physically when you get on a scale at home, right? Those numbers tend to bounce around a little bit. The same thing happens when you use a scale in the lab. And if you use a different scale, you might get a slightly different value. So the mass of an empty beaker is not exact, and you do have to consider its sig figs if it's part of a larger calculation. Same thing with the width of a room. Maybe you use a meter stick or some tape measure or something, but you're going to have that estimation piece. You're going to have to go one beyond the line. And because of that, because you're using a measuring device, it's not exact. And this last one here is exact. The fact that there's 360 degrees in a circle is by definition. We can't question that. That's like a known. It is what it is. So we don't have to worry about sig figs if you're using that value in a larger calculation. Alrighty, number 15. A meter has 1,000 millimeters in it. How many sig figs does this number have? This is a trick question. The fact that a meter has 1,000 millimeters is part of the metric system conversions. It's a metric system conversion factor. So there are no sig figs to even consider. It has endless sig figs. It's an exact number. On the next question, someone's trying to calculate the average height of students in the class. Which numbers in their calculation are exact? So think about this. If you were going to go calculate the average height of students, you would need to measure each student individually. So you'd have a whole bunch of individual heights, and maybe you'd use a ruler to get their heights. Well, once you start using a measuring device, you're going to have that uncertain digit, so that's not going to be exact. However, once you get everyone's heights, you're going to add them up and you're going to divide by the total number, right? So we need the total number of students, and there's no question in terms of counting people. We can't go one beyond the line or something like that with a person count. So that's an exact number. So at the end of the day, only the device, the precision associated with the ruler or measuring tape or whatever you use to get the heights will impact the sig figs in your final answer. The number of students will have no bearing on the significant figures. So a little bit of rounding practice to wrap things up here. We're asked to round all of these values to 3 sig figs. So 1, 2, 3, I'm going to cut it off after the 2. So on letter A, we're going to have 8.42. On letter B, 14.7. That's going to be my 3 sig figs. Always looking directly to the right, I have an 8, which is going to bump up the 7. So letter B is going to be 14.8. On letter C, this is where it gets a little bit tricky. If you have a very large number with a small number of sig figs, then you need to use scientific notation. I'm going to convert this to scientific notation before I even start worrying about the sig figs. So my decimal point would be here. So I'd go over 1, 2, 3, 4, 5, 6 spaces. It's a big number. I'm going to use a positive exponent. So 1.356,892 times 10 to the 6. 3 sig figs, we're just going to keep 1, 3, and 5. But I have a 6 after that. So my final answer will be 1.36 times 10 to the 6. Over here, 9.99999. And in the back of our head, we're thinking, if we round this, we're going to get 10. And you're absolutely right. So if I look at the 3 sig figs, initially I might think that I'm going to keep it to here. But that 9 is going to cause this 9 to bump up, which causes this 9 to bump up. And we're going to wind up with a 10 out front. And I need 3 sig figs, so I'm going to do 10.0. A lot of bumping up of the 9s in that example. Maybe something similar going on here, maybe not. We need 3 sig figs, and hold on a second, that's a big number. I can't just cut it off and write it as 200 or something like that. 1,999 is not anywhere near 200. Let's convert it to scientific notation first. So 1.999 times 10 to the 3rd. And now that I've done that, now I can work on the sig figs. So cut it off there. The 9 bumps up, which then bumps up this value. So at the end of the day, we're going to get 2.00 times 10 to the 3rd as our rounded value.